Okay, so welcome back to part B of experiment number 8. The setup that you see in front of you is the setup that you're going to use to study electromagnetic induction, and the equipment that you're going to be using, you are also going to verify Faraday's law. Faraday was, again, a young scientist like yourselves, and back in the old days, when, before they had iPods and computers and things like that, he would meet with his friends, usually about once a month at the time of the full moon, because it was difficult to get to friends' houses in total darkness. And they would share different things that they have discovered. And one of the things that Faraday discovered was that if you take a magnet and you wiggle it in front of a coil or a wire, you have a voltage that's induced in that coil or wire. But if you wiggle the magnet twice as fast, the induced voltage in that same wire or coil will be twice as large. And this relationship, this linear relationship between increasing voltage for increasing frequency, is now known as Faraday's law. And students are going to use this apparatus to verify that Faraday's law applies. Now, how are we going to set it up? Or, well, I'll let you figure that part out. But what I'm going to describe is the equipment that you're going to use to set it up. You'll notice here we have a signal generator or function generator. This will serve as our AC voltage source. Because we need an AC voltage, not a DC voltage like the battery provides, we use a signal generator. And the reason we use a signal generator rather than the electrical outlet on the wall is that here in North America, this changing voltage, which has an average RMS value of about 120 volts and a frequency of 60 hertz, is fixed. A signal generator allows us to pick the voltage that we want, the frequency that we want, and also the function that we want. It doesn't necessarily have to be sinusoidal. So this function generator or signal generator will be our AC voltage source. We're going to connect it to our solenoid. This large coil in your lab manual is called the solenoid. And because we are applying an AC voltage, the magnetic field around the solenoid will be changing back and forth. Now, inside this solenoid, we're going to pass another little coil called a secondary coil. And we're going to pass it in through here. And again, connect it with wires to a voltmeter. Again, I won't make the connections. I'll let you do that in the lab. And what you will notice is this. As you increase the frequency of the voltage that's being applied to the solenoid, the secondary coil will have a voltage induced in it that will also start to increase. And we will actually see what the actual value of this voltage is on this voltmeter. So as we increase the frequency from our function generator, the voltage that is induced in the secondary coil that will be recorded or shown on this voltmeter will also increase in a linear manner. Since a voltmeter actually gives us a time averaged value, it's not the actual voltage, but a time averaged value. This time averaged value is a special value called the RMS, or the root mean square value. Because our voltage going to the voltmeter is AC, changing with time, we have to apply this root mean square method to it to give us a time averaged value. If we didn't have voltmeters that gave us a time average value, here in North America, the voltages coming out of the electrical outlets in the walls are 60 hertz. It would be changing 60 times per second. And if it was changing 60 times per second, we would actually have to pop a couple of aspirins because we would get a headache trying to figure out what the voltage is that we're looking at. So that's why voltmeters have a time average value, the RMS value. But we are going to also use a special voltmeter called an oscilloscope. This oscilloscope not only measures voltage, but it also measures time. Again, in previous labs, you have learned how to use an oscilloscope. So when you connect the oscilloscope in place of the voltmeter, you will see an image of how the voltage changes with time. And once you get your values, you plot them on the graph paper, and once you see that you get a nice straight slope, you have verified Faraday's law. Okay, and that's it for this experiment.